Awesome. Well, welcome. Good morning, everybody. Saturday morning. Looks like everybody's up and at it. Today, we're going to be talking a little bit about electrification. I'm sure everybody's heard about that a bit, seeing kind of the addition of electrification. Hopefully a little bit of what you'll hear today is, it actually has been around a while it's kind of emerging in a lot of ways. It has been out for some time. As a guy who's been doing this for nearly 3 decades myself, including racing, but electrification being kind of what started and sparked that for me. Excited to see what's happening, and so you're going to hear a little bit myself and Rodney. So I'm actually the CEO of the Battery Innovation Center, which is actually headquartered here out of southern Indiana. And Rodney is one of our lead technicians, so former firefighter, I guess still a firefighter, but former firefighter that we brought in quite a few years ago, and today probably tests more battery systems and more battery technologies and chemistries in a week than most people have seen in their entire lifetime. So I'm excited to have him along with us to share about more about what we're seeing. So just a quick background, I always feel like it's good to have a little story. I'm kind of a storyteller, hopefully that makes sense. We have some technical presentations here, so we'll try not to kill you with too much tech detail. Hopefully it's a good mix of it between. But just for myself, I'm kind of an all-in technology gearhead. I've been a battery aficionado for a really long time, but really just a devotee of innovation. Today you'll find if you get to know me much, that's kind of, they always say powered by what? I'm really powered by ADHD and OCD. So if you're familiar with both of those disorders, as they would say, I call those enablers from my perspective. But it's been my privilege to work on some amazing products, some world-class teams all over the planet, on some really, really cool products. Anything and everything from performance to alike, and that's it's actually been on the internal combustion engine side and on the electric side for a lot of years. I think the exciting part for me is, it's now encompassed over 1 million miles of electric that I've driven on the ground. I lost track of in the air and on the water, and also some stuff that went to space as part of electric as well. So I'm excited to, for me, I'm at the 2 million mile mark in my life. It's literally a 50-50 split. I've been about half internal combustion engine, just over 1 million miles, and I'm now 1,020,000 and some change as of this morning on electric as well. So I've been doing this for a little bit, but as you can see, just some of the things I've been a part of all along the way. From, again, planes, trains, automobiles, land speed records, and actually some of the very first. In fact, that was kind of awesome to walk down yesterday because I helped with the Delphi Impact, which became the EV1. Helped with the advanced battery testing as a high school kid. Ironically, was where I started. It was cool to see that on the EV poster as a known capability. Again, that was back in the 90s. That was 1994. So it's been around for a little bit. So, and I feel old because I think I've been around for a little bit as well. So, as part of this, why we're presenting this and who we are, I won't give any more sales pitch in this, but Battery Innovation Center, Southern Indiana. We sit right beside Crane Naval Surface Warfare Center, 3rd largest naval base in the world. If you've never been to Indiana before, if you look it up on the map, there's no oceans. It's the only landlocked naval base. We sit outside there. Why is that relevant? We started working when we opened our doors, working for our warfighter. So helping them with their advanced power and energy needs, working with everything from what powers the night scopes and night vision all the way to literally what's on their submarines and on their battleships and on our men and women out in the field as they go on their peacekeeping and unfortunate engagement along the way. So that's really where we started and have worked with advanced technologies for quite some time. And you fast forward to today, we're really a commercialization center. So in about the late 14 timeframe, we took a pivot towards working with commercial entities, not away from the military. We still work actively with them, but they really had a shift as well. As it historically, military bought military technology. Today, they buy, especially from a battery perspective, very similar to what you're seeing in racing is there's commercial technologies. They buy commercial off-the-shelf technology and then they militarize it. And so it's been a little bit of a different shift. And so that's how we came to play. So today, we focus on really 3 key areas. You're always welcome to come visit us and meet Rodney and his team and all the others. But we advanced battery builds. We don't build our own product. We build for everyone else. So think of us as a fee-for-service provider. Just like a race car builder, an engine builder, we build batteries. You bring in your capability and your tech. We help you bring it to reality. We test and evaluate that. This is everything from single cells to, literally Rodney's testing planes, trains, and automobiles as well. Large scale, he gets to do lots of what we call rapid thermal events and then rapid disassembly events, aka fires and explosions. As part of that, and we do a lot of training and outreach as well. So we spend, our time all over the world helping people. Unfortunately, with safety events that do happen, by the way, batteries, can be unsafe, but plenty of you in here today have seen all kinds of gas air bombs, inside this facility. We don't refer to them as gas air bombs. They're internal combustion engines. We drove here, most likely in those today. It's because they've been designed safely, but they can fail. And when they do fail, they're pretty good events. That does happen with batteries as well. Welcome to the world of energy storage, whether that's stored in a molecule of gasoline or stored in a molecule of a battery or an ion of a battery. You're going to release energy one way or the other. You either release it safely or occasionally you release it where it happens unsafe. So, that's kind of the world we live in. And that leads into, as we think about, safety events, I think everybody, I'll ask by show of hands, is everybody in here through the glory of social media, if not personally experienced a battery fire, like seen one and understand that? Okay. I'm not surprised. I don't think I didn't see a hand go up. If you haven't seen one, welcome to YouTube. Just search battery fire. I'm sure you'll get plenty of hits. Trust me. You can go to any social media platform and see that. And that's the thing today is while we've got notable battery events and they've been out there, we've got, from laptops to planes. The military themselves had a multi-million dollar, the SEAL, or billion dollar, it was a $2.48 billion it was actually a secret program for SEAL delivery. This device, this submarine that was in the bottom left, actually, caught on fire, took an entire port, underwater out east. So it did, hundreds of millions of dollars worth of damage, in its case. But they also had the same thing happen with a large-scale submarine. Probably some are familiar with the hoverboard fires. If you get into racing, we've had some stuff around Tesla, around drag cars. We've had it around performance. We had it around motorcycles. So if anybody saw the TTXGP fire that happened, unfortunately, there was, the entire facility where they were storing all those electric motorcycles, unfortunately burned. And so, again, why we say this is not so that's, is our batteries inherently unsafe, is if I went and looked at internal combustion engines, if I went to the front page or the back page of the Star today, the Indianapolis Star, our local paper, you would see yesterday there was about 27 fires that happened in Indianapolis. They fit in a column about this big. They just put battery fire, or sorry, I keep doing that. Car fire, 38th Street, car fire, this, and the time. I can assure you that none of those made it anywhere on social media if you're lucky. But I can guarantee you if any of you had a fire on your cell phone in here today, it'd probably be published on the front page of a paper in China tomorrow. That's just how these unfortunately work. And so batteries are new. And our job here today is really to kind of demystify these and also help you understand, that there's capability that's out there, there's technology that's out there. And as you look at, from cell all the way to battery pack, the importance of what's coming along, what's been out there, what we're working on, and that just as we all, again, drive gas air bombs today that have been designed safely, and while they still can fail, they run effectively and efficiently, and we don't fear getting into those. There's no mystical thing about them anymore. We're just pushing the edge of everything. That's the same thing from a battery perspective, is getting a knowledge of what capabilities they have, frankly, how they fail, and then how do we mitigate those. So again, just like those 100 years of the gas air bomb, what do we do with that? We're doing the same thing with batteries as well. So the other thing to note, so just some, helping you with some language around battery is also, and there's all kinds of batteries, by the way, tons of different chemistries. As a guy who's been around literally all of them, I started on lead acid and the nickel metal hydride and then NiCad, and then obviously lithium ion, was just, literally it just got invented about the time I started doing batteries in the mid 90s. We're going to focus today on the advanced lithium batteries and some of the advanced chemistries. So these are the ones that you're going to see are powering most of your devices today, from your cell phone all the way to electric vehicles. You're still going to see historic lead acid, and that's still used as a house battery, still used as a starter battery. Those are still prominent. They're not going away. Just the same today as I get tired of hearing, battery folks mandate batteries and that batteries are going to replace everything for internal combustion engines. I get so sick of hearing that. As a guy who is a firm believer in the internal combustion engine, I hope that when we look at the racing world, when we look at the dealer environment, we look at what you can go on a lot and buy, or we look out in the world, 15, 20 years from now, I pray to God it is not entirely electric. I'll just tell you that as a battery guy. What I hope is is that we see diesel and we see advanced internal combustion engines, we see electric, we see hydrogen, we see fuel cells, we see natural gas and propane and all these others. The idea is about more technology, not about replacement of technology. Now, if the market decides to replace that themselves, so be it. There's the whole there's the whole Beta versus VHS. Well, we know who won there. The market decided that. But there's also the Apple versus Samsung, if you will. Nobody's won there yet. So I just want to say, as we think about, these advanced batteries, we're talking about what's coming along and how do we include these technologies out there. But, kind of some of the demystification is you hear about lithium battery, and for all of you, if you're not familiar with that, there are a ton of different lithium-based chemistries, and there are also how they're using, what type of lithium they are. So not only the subset of chemistries for the anode and cathode, but we start with what are lithium metals? Again, this is one that's like your coin cell and alike. Everybody's hopefully, if you got a key fob, I don't remember if I brought my key fob, but if you got a key fob in your pocket, most likely it's got a lithium ion coin cell, a lithium primary, which is a non-rechargeable lithium that's inside of there. See that in a lot of kids' toys and stuff as well. But that's a primary rechargeable, been around for, kind of the beginning of lithium batteries. And then you've got lithium ion, and again, there's some misnomers here where people say like, oh, I'm using LiPo versus lithium ion. By the way, those are the same thing. Lithium polymer kind of got edged up because of RC cars. It's not any different. They're both lithium rechargeables. There is literally no difference in those two. However, as you get into those, whether you're running a lithium rechargeable ion or polymer, again, same name, same thing. There are a ton of different chemistries. Today, there's about 14 fundamental chemistries. I threw some on here that most of you are going to see. I would say it encompasses, as I walked around yesterday around the show and just was looking what's in people's products, what's in like diagnostic equipment, what's in, our EV vehicles, I think that kind of sit below us as well. You've got, everything from lithium iron phosphate to lithium cobalt, lithium manganese oxide, lithium titanate, nickel manganese cobalt, nickel cobalt aluminum, which are your nickel based chemistries. Again, I won't bore you with what all those chemistries are. If you want to know the variations in them, it's kind of like fuels. When people say I got petrol or fuel, what do you mean? I got diesel, I got premium, I got all fuel, I got aviation gas, I got race gas, I got two-stroke mix, all those kind of things. It's same thing of saying fuel. Think about that. The same thing from lithium ion batteries for rechargeable. There are a ton of different parameters, if you will, a ton of different octanes, if that even helps you kind of understand and wrap your head around that. And inherently, some are more energetic than others. Again, think about fuels today. They're much more energetic. Our nickel-based chemistries are ones that are much more energetic. They provide a lot more capability, but kind of similar to, if I grab a cup of gasoline and a cup of kerosene or a cup of diesel, and I throw those two out on top of a fire, I can assure you they're going to do two different things. Most people are not going to be dumb enough to do the gasoline. Some may do the diesel. It will still burn, but it just has a different reaction. It doesn't mean it's less safe. It just means it's different. Same thing here. As we look at these lithium chemistries, you're going to see differences in how those react. And I think that's also one that I would encourage you today, if anyone says their lithium ion chemistry, their lithium chemistry that they're using is safe, it doesn't burn, doesn't have any other issues, that's the kind of the equivalent if I hear people used to say that about diesel fuel. They're like, diesel fuel doesn't burn, it's not safe, or it's not unsafe, it's less risky. That's really the key, is actually it's less risky, it's less reactive, but there's still energy that can release there. We're also looking at, there's some advanced ones that are out there, so there's new, so lithium ion isn't the only one. We've got lithium metal. So lithium metal is actually coming back online as well, but now in a rechargeable format. And I think most people don't know that because we've always had kind of, lithium rechargeable, lithium metal, and most folks knew lithium metal, once I use them, they're done. They are highly reactive. They are the ones that, normally if you would spray water on those, you're gonna have a very, very violent event that can happen, but they're usually small scale, so most people wouldn't see it. As we get into lithium metal rechargeables, now we're actually putting large scale lithium metal back inside of those batteries, and we have to understand as we're building those that they are highly reactive. Again, it's putting gasoline inside of putting race gas inside of there, or alcohol. Even if anybody's familiar with an alcohol drag car, hopefully you are, being at PRI. I mean, you look at how reactive alcohol is, how fast it evaporates. It looks very similar to lithium metal. It is kind of on par if you think about fuel versus battery. Lithium metal has some tremendous capabilities, and while it's emerging for rechargeables, it's also very reactive, and so we're really having to focus on how to make those safe. We get into some other advanced oxides and sodiums. Probably everybody's heard the solid state. Same thing here, they talk about solid state batteries. There's a ton of different chemistries that are there as well. So you're not looking at any one. You've got, and it's funny because they say solid state. The understanding is that's supposed to be ceramic, non-liquid separator. It's supposed to be all solid. That's why we use the name. Not really. I mean, there's solids, there's semi-solids, there's polymers. You've got bulk versions of that. They use powder base that are being used more for kind of your electric vehicle and large format. You've got thin film, which are these layered structures as well that are emerging. And then we have some other chemistries as well. One unique one that's coming along. You've got silicon oxide chemistries, you've got lithium sulfur, zinc ion. Won't bore you with those, but lithium air is actually kind of a unique one. It's where we're actually using lithium metal with a membrane, and it actually uses air as its reactor. So almost like an internal combustion engine, I've got gas and air that's inside of there. We actually have cells today that use lithium metal, and then they actually breathe natural air that actually causes a reaction that we want and actually powers devices. In fact, the military today, we built some of the very first lithium air batteries that actually don't require an electrolyte anymore as well. So some pretty cool stuff that's happening. So what I'm going to kind of cover high level, what do we look at as we think about, talking about advanced batteries, talking about chemistries, let's talk about, kind of the hazards that are out there. I'm going to move through these pretty quick because the idea here at PRI is for Rodney to share how does this, you're all going to say, how does this apply? This is all great technical information. That's really hard to disseminate, or I don't give a shit about that. How does that apply to my life? What am I doing here? What am I looking at, or what am I considering? As we think about these, it's just like any other energy device today. We're looking at how do we identify and address hazards. That's really our job. And these cover across the sectors you see here, from energy, electrical, mechanical, chemical, and control. And I think the biggest thing to notate is this is the first time a battery today is the most dynamic device you will deal with. It is a combination of electrochemical and mechanical. If you look at any other device we're dealing with, go out here on the floor, look at internal combustion engines, look at the electronics, look at it, any other object that's out there. It's either electrochemical or mechanical, or it's some combination of two. There is no combination of three. The only other combination really of three is animals and humans, and organic objects around us. Otherwise than that, every other object we normally deal with is only one or two of those. And so it's highly dynamic. We have to understand from all different factors, what we're handling here. And so as you look through batteries, and again, these are to help kind of demystify some things, is we've got, around the energy side, we're dealing with, today flammable electrolytes that can combust. Burning is pretty typical. Explosion can happen. Again, back to, what you happen with fuel today. I don't think anybody's surprised that, fuel does these kind of things as well. Probably one unique one here, though, is the intense sustained heat. Rodney will talk about this a little bit, but, where we see, most gases, burn somewhere up to about 1700 degrees C, at their max capability, but they usually do that really quickly. It's usually the flash point, and then it lowers. With batteries, we're seeing sustained at 2,000 degrees and above. So we have some that have gone, north of 2,500. There's been records of nearly 3,000 degrees centigrade, which is, again, 2 or 3 times the heat that you're actually seeing come out of the best fuels in the world. So sustained heat, we can use that to advantage, but it's also a safety factor. And then a new one here is you got voltage as well. We haven't, nobody worries that a cup of gas is, going to electrocute you. You probably worry, get it on your skin, it'll dry you out, or, a chemical reaction. Again, it's it's got energy and it's got a chemical reaction, but it doesn't have this voltage reaction as well. We're looking, systems that we test today. Prior to this presentation, average has been, getting close to about 1,000 volts. We've got some new systems online. We're actually working on some updates where we're doing 1,500 up through 2,000 volts. So DC, by the way. So, massive. A lot of the vehicles you'll see downstairs, I don't think anybody down there has got anything over 800 volts. I'm not aware of any. You have to look them over a little bit more. But we have active systems in our building today that are going into the market. Literally, as you sit here today, there are systems on the road today that are 1,000 volts, 1,200 volts. There's one that'll be out July of this year that's 1,980 volts max charge. So it's nearly double what you see downstairs. So the amount of isolation and stuff you're going to have to deal with is there. So you've got, again, some unique things around energy. Around the electrical side, again, I hammered on that a little bit. You also deal with, we've got advanced electronics inside these, so I'm having to deal with electrostatic discharge. So I've got to have safety controls. I've got, just like the rest of my vehicle, I've got critical safety controls that are on board that are doing all kinds of functions along with data logging. We do combinations of that as well. I need this, all of these advanced batteries require what's called a battery management system, a BMS. If anybody's got a power tool and seen the little red light, green light, yellow light, or look at your cell phone, and it gives you some diagnostics on your battery, it's those on steroids. So, again, probably the best analogy is an engine control. In fact, it's kind of funny, I was just talking to somebody the other day, as we talk about, systems that are reused versus replaced. If you go downstairs, even like AM Holly and some others, you look at some of the controllers, those are actually engine controls and body controls. They've been converted over, reprogrammed to control battery systems as well. So again, back to that, I always hear that, the battery is going to replace, automotive as we know it tomorrow. It's not the case. I even heard that. They're like, oh, engine controller companies are going to go away because, we don't need engine controllers anymore. And it's like, no, engine controllers are amazing battery management systems. They're smart brains and data acquisition systems. So some opportunities there. And we talked about, this dynamic device. We've got mechanical included in here. So not only what the battery can do when it fails, but also all the balance of the systems that are around it. So similar to an internal combustion engine today, you've got a lot of other componentry that's still there. All these pieces and parts are still an active part. One other unique one, and these really kind of supersede what we're all used to is around the chemical side, is, these do, unfortunately, when they release in an event, they have similar to what you have with internal combustion engine, plus more. And I think that's probably the most notable as we think about, for folks that are building these vehicles, that are using these vehicles, as we think about sanctioning bodies, as you think about companies that have got these products inside your building, you're having to deal with a new set of standards. And again, I don't want to get everyone freaked out that that this is just an instant exposure. These are at failure point. So similar to nasty stuff that gets released when you burn or explode other things, that that can happen with battery as well. But there are some unique components inside here. Specifically around as you look at HF. So we get HF gas, hydrofluoric, which either turns into is a typical vapor state. If you spray water on some of these, you can actually turn it into an acid. So as you think about cleanups, how are you going to do this for contamination? You've got fluorides and others that are in there. Again, we're working on methodologies to reduce some of these organic components that when they break down, again, they're naturally occurring, but as they break down, they produce some of these factors. We're working on ways to actually make those better. The other thing to keep in mind, and Rodney will share on this, is that battery fires today, you don't put them out. There's no such thing as a battery fire extinguishing. And we test, trust me, there's plenty of great products out there that will extinguish a single format. In some cases, a range of chemistries. They may, help a particular chemistry, but there is not a one-size-fits-all today. Not today. I will say there's some good ones in the work that are really moving to try to cover a full basis. But even the encapsulants and others, and I'm not going to use any names out here. There's plenty of ones you've all heard of. They don't work 100%. They don't work on every application. That's because there's too much emerging on the battery side for them to keep up with. We always, we're one of the places that test a lot of those, and we say, hey, that works, but here's the caveat, so that people understand, what they may be doing. So as we think about, working with first responders and working with tracks and working with builders, working with racers, helping them understand what do you have and what are you using and where are you headed with it and what's out there and what might be in your toolbox, so that we can help arm you with the best stuff. Because again, does water work? Yeah, sometimes, but other times it's really, really bad. Does foam work? Yeah, sometimes, but other times it's really, really bad. All these different capabilities that are out there, we got to be thinking about how we handle those. So, and then again, just kind of talking through for any of the chemistry or math geeks or engineering geeks that want to know some of the ranges. This is just some ranges, so if you want to take a picture of that, you're welcome to, or we can get you a copy. But if you want to know what's being released in the quantities, the key is here for anybody that's chemistry, you'd understand most of these are really, really elevated levels. So when we have a failure event, they're very, very notable. So, we always hear people is like, oh, I didn't, small fire, it was a little tiny battery fire. We didn't think much about it. We have had, events where even a power tool fire was enough to put somebody in the hospital, and they found out later that they had, advanced bone marrow or advanced bone degradation from literally just a few moments of exposure to the HF that came out of a small battery pack. So when I'm talking small battery pack, like power tool battery pack, anything that you've seen here today is a pretty good sized battery pack. So there is a risk in that exposure to have those kind of things injected into your body that create, long-term degradation and even eat at your bones, literally from that perspective. So it's important to be thinking about from a safety. And then ultimately what we're going to try to push here is helping you get to an understanding of what we call known and unknown state. And I think that's the same thing that we really want to help with batteries is we want to help you get to the known. Again, they're really not that mystical. There's not a lot of crazy stuff that people just can't understand. It's just wrapping your head around kind of concepts you've had before as a combination. And so that's really the key that we use and we help our teams with is really what's known, what's in your unknown, and how do we move that to a known state. Rodney will cover a little bit on the PPE as well. So, if I leave you with, and then I'm going to turn it over to him, is, again, this dynamic electrochemical device. They will happen. They are rare today. They are a unique reality. If you think about the number of deployments, if you knew how many of these products were deployed here in the U.S., does everybody in here have a cell phone in their pocket? Do you worry about that cell phone in your pocket catching fire and killing you? And no, in fact, you take it home and plug it probably in beside your bed, each night, and it's in your pocket all day long. That's what happens, right? You're using very similar to what, using exactly what's out there in a lot of different products. So they are rare, they are unique. And today, because it's really kind of the unknown, they seem to make front page news. I will leave you though with, battery fence are irreversible, at least as you see today. And they can be long duration. What are typical where we actually put out fires? That's what Rodney's been taught all his life, is to put out battery fires. He's having to learn actually how to encourage fires to continue in a controlled environment. So no longer firefighting, but fire control and fire mitigation, so that I can make the battery fail the way I want it to, put it into that known state versus its own known state. And then, thinking about through event measures and severities, and then we've got, chemistries that are advancing that are helping make this better, similar to fuels. We've got better and safer, more capable, higher performance fuels. We're doing the same thing on the chemistry side with batteries as well. So what I'll leave you with before I turn to Rodney is that there is no one size fits all. So, even from a battery perspective, I hear that, everybody's, especially as a battery guy, I always say there's kind of lawyers, liars, and battery suppliers. But I got tired of offending my friend who's a good friend of mine who's a lawyer. So, we tell folks with batteries, our job is to help them kind of go out into that farm field of batteries and not step in any shit as part of that. So hopefully that helps you a little bit with how do we get you to known state. So with that, I'm going to turn it over to Rodney for a little more discussion on practical applications. So.
That was intense, wasn't it? There's a lot there. It's a whole lot to unpack. So, yeah, I'm going to go into this too, give a little breakdown for myself. Been with Battery Innovation Center now for going to be on 5 years. Day one, pretty much came in there, got my mind blew on some of this. I'm a conventional engine guy. I was a nice guy. I spent 15 years in a shop building chassis, semi-local here, 2 hours south of here actually, at Checkered Racing. On top of that, I also worked along with a pro rider for Kawasaki, was quite used to going around track settings and obviously building cars. Nice thing to do front ends and everything else between here to the front to the back of a 9-inch. So stepping into this world really didn't change much. The only thing that changed was instead of me having 100 gallons of race fuel in my shop now I've got like 400 kilowatt hours worth of batteries laying around that I get to play with, and I don't have to worry about smoking around them. So that's a bigger deal.
You can give mine again if you like to, Ryan.
Like I said, been in the chassis world, building cars, racing, lightly, have some friends on the car side, worked a little bit on Kawasaki. Going on 8 years in the fire department. Hard to believe that I'm in Green County, jumped in with Taylor Township. 4 years later, I was president of the fire department. We're a pretty small district. Average right now is about 400 runs a year. After that is, I'm old lady, fell down, can't get up. Not necessarily the big fires that we want to get used to, but we have plenty of exciting things going on around there along I-69, about 90 miles north of I-69. So we see a fair share of crashes, fires, houses, and then along with that we have a few major shipping transport companies that you never know what they're going to have whenever they have something good on. Coming into this, I realized that there's a lot of information that just wasn't getting passed down to the first responder or the tracking. Here in this last year, it seems like the tracks really ramped up and we started getting phone calls. I will say that more than likely, if I pick 3 questions that you're going to ask me, I know what one of them is, and it's about always how I put it out. From a firefighter perspective, I've always been trained to come in and actually just go in and knock it out, knock it down, save lives, save them, save property, and then go home hopefully by 4 a.m. Working along with batteries, that's not necessarily going to be the case. You're in for the long haul. Touching base on that, of why, and I'm going to get into that a little bit on detail. Not too boring because it is fire related. So, as a firefighter, do we have any first responders here or anything? Yeah? All right, got a couple. All right, you guys used to seeing this fire triangle. This is pretty common information here, how this goes. Oxygen, heat, and fuel, that's what we're used to playing with. The difference when you bring that into a battery is you're not able to lock some of that out. The oxygen is internally sourced with lithium ion. Whenever it starts degrading, it starts actually breaking bonds and putting out oxygen inside the cell. So fogging it with water and foam is not really going to do anything because it's just going to sit inside that bubble and make its own heat. Same thing with heat, it's chemical reaction or it's electrical. So energy is being put off internally in there and it's going to build its own heat. Chemically, that happens inside the cell a lot of times. And I do not have a video in this one, but I have a video that actually shows that chemical reaction happening. Luckily, on the outside of the cell, what is pretty amazing you can see. Fuel, it's not wood, it's not cardboard. Inside here, most of it's the anode capping material is going to be aluminum, copper, and then there's some polymers and stuff like that. There's too broad to get into detail on what all's in there, but know that when it does go off, aluminum and copper becomes liquefied and obviously starts burning, and that's these elevated temperatures and debris that we start seeing. That from a safety perspective, your suits, what I've been telling fire departments right now is like wear full bunker gear for just a common small cell scale fire batteries. The main thing for that is that the fires that I've seen and caught is elevated temperatures that will touch base on that. Going into a little bit on the battery side, we've seen a cell break down here. Since I've seen a cell, I got one of these in my pocket. About everybody has a bunch of them in their wall, Milwaukee, Kia, whatever that is. That's what a lot of these are nowadays inside them. This is some new formats. These are what we call cylindrical, prismatic. What's inside here and here is this is a pouch cell. So there is a big push right now for pouch cell and prismatic. You get a large format, you get a lot of capacity, and you're able to design them to suit your application a lot more. And then you can step that up into a modular format in a pack. So breaking that down, cell, module pack. That's most designs for batteries and EV related vehicles right now. We've used brake open at Milwaukee. We're not going to call that a pack. It is a pack, but it's really just a few cells stacked into a module. The problem with a lot of that is that they're not been touch based on the engine controllers that we have now, and you can just plug in, start tuning your timing, air input, and fuel input. With the BMS system, a lot of them are not quite that educated yet. They're more of a monitoring system. They're not active. They look at a battery and they say, "Oh, this can get a little bit warm," and at best case, they throw a little flag. Not necessarily that it goes in there and isolates the problem out or tries to prevent it. There's a few systems that do that, but more times than not, it just throws a red flag or we'll just shut down at best. Talking on that anode cathode material, this is pretty much what it breaks down. If I take this flashlight out of my pocket and cut it in half, that's what it's going to look like on the inside. That's the material that's going to be spitting out. I have a few photos of those to show that, but it's all infrared. What happens is as gas is building up in here, it's heating up, gas is being generated, and there's a large amount of gas for a cell for something this size. That gas then is built up to the point that there's a release point on top of this one of these 18650s. Now when that starts releasing, it tears the anode cathode up, it gets in the way and either plugs or it gets superheated and comes out of the molten metal. These are temperatures that it's very hard to track. You're looking at some stuff that's just a little bit smaller on a dime, and then in many cases it's very small particle sizes that are flying at pretty good speeds across the room, and then actually with my infrared camera I'm not able to capture the temperature 100%. It matches out at 2,400 and some change Celsius, so I'd have to do the math on that, but that's pretty hot compared to what most things are now. Why I'm bringing that up is because most of the gear that we have right now, I use welding blankets at work, and we're all familiar with welding blankets. They do pretty good at catching slag. The welding blankets actually do not hold up at all to the release of that anode cathode material getting spit out. It just shoots right through that fiberglass blanket that's rated up to minor for 1600F. And then cuts through there like it was just hot. So that got me concerned about track setting along with fire departments when you start talking about a large scale for the EV system here, is that we need to start talking about and talking with suit manufacturers about being prepared for this next step. The temperature that we see here is, the highest rating is a 20, I believe. I have to go back on that, but the highest suit rating that I've seen on a track setting is mostly just going to be for the
SFR 20, yeah.
yeah. What was that? Sorry. Funny cars.
Top fuel.
Top fuel, sorry.
Which is funny car actually.
So the top fuel numbers that they can sustain to, we're close on the number. The problem is top fuel burns like that, and then it's a lot less of a temperature, like they were saying there. It builds up and then quickly comes down, and it's just sitting there burning across the ground. I wouldn't say walk across it, but it's dumbed down a whole lot within seconds. With a cell level event, you'll have at each cell for 3 seconds to spit that temperature out, and then transfer that into the next cell, and into the next cell. So you can have a sustained burn that is just constantly raising and lowering the temperature with a common size EV car that we have right now. You're only sitting there for 2 hours if you don't touch it. If you go to touch that vehicle and start putting water or something like that on there, that temperature is going to lower, and then you're actually just going to make it burn longer. So I mean, you've cooled it down, but you're not able to put that out because of the internal fire triangle that's happening in there. All you're doing is actually just slowing it down. Now, in the best case scenario, we use that scenario to slow it down and pull it down just enough to move it off the current setting that we have it in, and get it in a place that we can mitigate it, control it, and get it out of harm's way. That's something that the tracks are going to have to talk about. That's something the fire departments are going to have to talk about. If you're not willing to allow it to burn, then we're going to have to figure out where we can set this thing up and then have qualified people to either tear it apart, Now obviously we're battery people here, but like I said, we're ice engine people too. I just sold 454. Not that I'm trying to sell it again right now, but yeah, this is something that we mess with. We don't want it to be, I hate talking about it a little bit because it seems like I'm trying to scare people off batteries, but like I said, I actually have a ton of them at home. The problem is not the battery. The problem more times than not is that somebody designed something not right, and just like I wouldn't be over there smoking next to my race tools. It's just somebody improperly doing something. Or the BMS system should be more capable of handling a few other items in there. There's some designs that work, but when you start pushing in designs to the max, then you can start incorporating different items into that. Going into that, like I said, track setting, turnout gear. The only thing I've come into a battery fire right now is a full bunker gear, and I'm going to be nervous if I have to take direct impact. The problem is that each layer of these suits are rated as a layer, and then you get a certification once that layering has been tested, but there ain't a solid number tied to that after the fact. And then the batteries, how much degrading happens in that short amount of time that you get exposed to some of the acids that are inside there. How long is this my gear going to last? These are numbers that we don't have, and I'm trying to push companies to help us fund these projects to get going on it. If they want to keep pushing vehicles out onto the track and out on my highway and interstate, and I want to know how long my gear will last. Right now, it's 10 years before I'm liable to have to change my gear out. But if I have to start playing around with HF and some acids once a month in a vehicle fire, I'm going to say that's probably going to cut that time in half in weeks. The threading is going to start breaking down much faster on all of that. And being a small department, that's something to think about. Obviously, it's we're 15 guys and 40. We're in gear right now. It's going to be close to $40,000 for 15 guys. So I mean that's a pinch. And taking next steps going into actually looking into gear and building proper gear for this would be the way to go on that. It does not. I do apologize.
Saturday morning, it's looking up.
There you go. Like I said, elevated temperature. All right. Thanks. So this is reading in Celsius, and this is time based across the bottom in Celsius on it up and down. We're talking in seconds. So you can see in 3,000 seconds how many times I've had a cell, this is in a module, go off and just completely blow out the current thermocouples I was using at that time. 1400 Celsius is not something you want to be playing around with. I promise you that thing probably shot more like 2400. I just wasn't able to capture it given I was melting my thermocouples. So that's something you just actually have to go into and think about from a testing side, that most of the testing equipment that we are used to in a vehicle system is not going to hold up some of these temperatures. It's going to fall and break down. And that's pretty much what happened here. It just overshot that number of thermocouples. And when they finally come back down, I was able to make a connection again. I'd have to do that math for 3,000 seconds. Yeah, I mean, that's more than a minute. I can't. What was that?
Almost 15 minutes.
Yeah, that's what I was thinking there. But you imagine an hour, and about every 20 minutes we have this venting going off. This is something we're not, my gear's not used to. That's a lot of energy. And it's just in an unknown state that we're talking about. That's the known versus unknown. I'm walking into this right now. I know it's on fire, but how much more, how much longer it's going to go? If I go to putting water on this, all I'm going to do is drag that timeline out. Water by itself. There is some chemicals that may, depending on the chemistry of the battery, help that long, but the idea for me is I'd rather, if it's just a car on the side of the road, first off, the insurance company is not going to rebuild an ED if it catches fire. They're going to be told, your best thing is just to let it go from the first responder side. If you can keep people out of the gas and keep the flame off the other people's house, off of other houses and homes and stuff, I'd just let that thing go. You'll be done in 2 hours, and you throw it on the tow truck and you'll be home. As soon as you start putting water on there, you're going to be dedicated to that thing, and you're going to be dedicated to the tow truck. And anybody around that truck. And a lot from first responder attitude. More than likely, you'll be going back to the lot after the car reignites from that chemical reaction inside the cell. And then you'll be putting the car back out again, probably about 4 or 5 hours time, and you'll probably be there again the next day. So, I mean, as soon as you start applying water onto something, you have now dedicated yourself to that. As soon as you rip that hose off the truck. And with batteries, that timeline really gets stretched out. Here's some temperatures that we talked about. You can see this. This is an 18650. Actually, it's identical to the one in my pocket. That's kind of like custom. I do love them. They are great. But you can see how much debris is actually being spit off that cell to the right. Again, the temperature in the center there, that whitish looking spot, too high for my thermal temperature catch, and or at least for that setting and that time frame. But I've definitely seen 2400 Celsius, and I believe there's more room to grow in that temperature range. Now, gasoline and ethanol, you can see is pretty low. The interesting thing here is once I got to pull in, because I didn't realize thermite. Anybody here know what thermite is? What it does? Yeah, that's fun stuff. The fact that they use it to melt railroad tracks together and burn through ships that, like warships that burn through make holes, that's interesting. So the temperature I've seen is actually hotter than thermite. And I don't think anybody's actually ever thought of that or actually found them numbers, but these are things we're going to have to really think about. And I can promise you, about the track suits that baseline suit right now is not great for that. It's not going to hold up to that for seconds. You'll be lucky to get milliseconds out of that before you're going to get third degree burns out of that. Kind of just relapsing what we went over a little bit here. This is more from a first responder attitude. If you want more education on batteries and battery tech, I would say feel free to give us a call. Come down here. We get tours every day, and if you get it at the right time, I'll let you push the button and you can blow a battery up. So feel free to come by. But next steps, definitely training. This is something we do right now. Just was up in Chicago last week, trained about 45 firefighters that had a pretty nice, decent area that had already had 3 different battery-related fires.
Yeah, we were up in Chicago Fire and Morris Fire. They had a 1 million square foot facility that burned to the ground. Was an active fire site for over 92 days because of the 7 methodologies. They started with water and then used a bunch of others. 90-some days later, that site's still on fire. Then we had a nuclear plant. Beside that was renewable energy. There was a fire there that was the largest scale. The plant was the largest battery fire in the world. We know by land mass. The largest battery as a system fire happened 20 miles from there, and then one of the largest vehicle battery fires happened just outside of Chicago. So they got 3 for in less than a year and a half. Had major events that rallied all their fire team and taught them they didn't know what they thought they needed to know, and outdated techniques in a lot of ways as well. From a battery perspective.
There's a difference in the 2 events that happened there. The first event where we met and we made phone calls, called them, we've seen that they was having an issue. We wanted to try to help out as much as we could. At the time, we wasn't able to. So there was some bad tech that had come down. The second event, they called us day 1. We went out there and helped them with that. The difference is the second event is cleaned up, done, and that facility is back operational. The first event is over a year now and still trying to get cleaned up. And there's still reactions happening, there's still heat generated, and there's the hazmat cleanup side, so it can be quite intense if you go in there and just start spraying water. First responder, we've been taught Dan died converted with battery. batteries, the wording one time there, and I'm trying to break it, is copious amounts of water. I hate that. And I don't even want to use water on it. I said, all you're doing, the way the cell is designed to hold everything inside of it, and now we think we're just going to be shoving some water out. That's maybe getting to it at a few PSI. So copious amounts of water is doing nothing but grabbing the heavy metals and debris that would burn up inside the pack and washing that out onto the track and into the grass and down into the neighbor yard. So I would heavily advise against just throwing the water out. The only time I want to utilize water is if I have somebody in traffic and I'm trying to do some cutting or try to just push the flames back. That's the only reason to use that water is mitigation. Get that fire off the driver, get the fire off my guys, and or once that's out, once you've got your driver and your guys are out, let's now reassess the situation and go forth from there. PPE, electrical, chemical, like we talked about there, definitely want to look into that. Obviously, there's voltage in this stuff. Most of our gear is not rated for 2400 volts. None of my gear actually, I'm sure it has A rating, but I know it's not. What that is I'm not allowed to mess with power lines. So I can
Does
set
cal
up.
rating come into your PPE that you use in your teardown too? So those two things start to mesh between what the cal rating versus the fire stuff is?
Yeah, well, answer some of that question is, the cal rating that stops at 1,000 volts.
Right.
You just heard earlier, we've got systems on the road, you'll see on the racetrack that are up at 1,000 already, and they can break down. The gear won't even stop the breakdown.
That's where you get to the next level of gun suits, yeah.
Classifications, I just want to see some more standards come out. Some of the standards we have right now, battery companies and manufacturers are using UN 38.3 as a baseline, saying that, we pass UN 38.3. I do UN 38.3 testing every day. It's a shipping standard. It means I can ship my battery on the ground, UPS, to one place to another.
It's not a safety standard.
It is not a safety standard. There's nothing about that is really built around your safety. Batteries will, if it passes that, like I said, that just means it can go in a box and you can get shooken up a little bit and then it can go in the truck. So I'd like to see more standards get built around that. SFI, along with FDIC that we're working with, trying to get some new standards for fire departments, training and things like that.
Yeah.
All that needs to get revised, looked at. The current first responder training for battery fires, there's key notes, key points, and a lot of outdated information in there. So I went ahead and took that class over again just to see if there's anything new in there, and it was actually pretty sad how outdated some of that information was. Like I said, we talked about responder mitigation, monitor influence, controlling the site versus just trying to go in and put it out. And then large format things that we're starting to see. Not so much here. You do see it here in Indy. If you drive around town, there's some areas inside this town here that there's actually lithium ion underneath the concrete. It's something that telecommunications use very commonly in telecommunication along cities. And then once you step out and get into the suburbs, you start seeing some of these solar panel farms and along with nuclear power stations not that we have anything nearby. Lithium ion is being utilized at them locations to store energy. So it's something to think about. It's been around us for a long time. It's just now the news has really got onto it the last couple of years. And they act like every time you look at it, it catches fire. I do this every day. There's days I cannot make them catch fire. That's in my first month I got handed 1,400 cells to test and do nail pin, overcharge, over reverse polarity, about anything you think of. Some days it does not actually catch fire. So that is not always the situation, and just because you held your tongue wrong doesn't mean the battery's going to catch fire. Know that the news definitely plays that up a little bit more than it is. I have a video, I'll play it, let you guys watch this one, and if you guys have any questions or anything while this is going, just feel free to step up and talk. I'll cut the sound off on this so that you don't have to talk over it. But right here, this is a BMW i3 pack that I've done a nail penetration. You can actually see my engine in the background. Things to note here, It was not raining that day. You can see there's about a 4.5 foot gap between the top of this pack and the top of the Connex, and then there's about the same amount of distance on the bottom. As this is playing through, I hope. The Connex actually got hot enough that it was actually bowing down the top of this Connex. So, I mean, we had heated the Connex up enough that it became an issue. And after this test, there's a few other customers come up with like, oh, we'd like to test what happens if the whole Connex goes up. The Connex is not going to be there at that point. I know this now, just going off this. So the Connex actually, the ceiling was bowing down, it was red hot, and that's why the ground is wet, because actually pulled it and dumped about 1,500 gallons worth of water, just misting the area, keeping the Connex pulled down.
And there's actually debris in here that's actually going through the Connex container. So it'll actually melt through the Connex container as part of that as well.
The thing to think about from a first responder setting is, like I said, if it is an OEM, it's total insurance. Quick note on that, like I said, Connex top of the building, red hot, blowing hot. You know, there's a plastic container that I accidentally left down here, never can get burned. And it's just a cheap plastic container I was using just to store a little bit of the Connex in. And I meant to throw a little bit of a heat shield over it and forgot before the test.
Fifth the cell to start the event, right? A penetration test to start that event.
Yeah.
And from the beginning with no water mitigation, you just let it go through the I3 back from beginning to end.
That's correct, yeah.
How long did it last? What was the delta of time that it lasted the event from beginning to end without watching on video?
There is 2 hours, close to 2 hours. Just
2 hours,
this,
okay, all right, yeah.
So, I mean, this hyper-aggressive jet flame is about 2 hours.
That's why it's going to keep what's the exothermic reaction, and it's going to go with exhaust. Like
Yeah.
It propagates because it goes through the cells as it goes down and gets off. It propagates.
Correct. Yeah, and this was I mean, this can keep in mind this pack has, in this specific instance, this is a variant. This is a custom variant where they were looking at an advanced thermal material inside of there and a fire mitigation material that we're supposed to eliminate propagation. So now
That's why you're seeing it go there until it burns through and it fails, and then it goes to the next thing.
yeah, is specific propagation event that it was supposed to stop propagation, eliminate it from going to the next cell, be able to keep that.
Yeah, but it didn't work.
Actually didn't slow it down at all. The event versus the original event was exactly the same. So they put a ton more engineering, a ton more product. I mean, in their case, they would say, they kind of said they got sold some snake oil on how to make a battery safe. I will tell you the other thing is, in the instance of that, they also slightly changed the format of the cell that was inside there, which was one contributing factor. Number two, they worked with a new chemistry provider, still an NMC chemistry, but they adjusted a little bit on what they were doing with the NMC. So at the same time, you know, that they were told this would fit, you know, NMC chemistry of a prismatic design.
Right.
And unfortunately, as you'll see, it again, it continues once it gets to full scale. So at this point, internally, the pack, the full scale has already started. I mean, that reaction is all there. So.
And to see how this applies to racing a little bit, to get into that, is what we have to design right now. The rules that we're kind of working on right now is we have to protect. It's just like a fuel cell for a car, but the gas is inside. What we're trying to do is design the pack the batteries go into of. In a race car, and it's trainer conditioned to do that, they're pretty good, but you've got to rely. They use a nail test on a chassis, a wreck. We've got to design so that the part that the batteries are contained in can withstand, so that doesn't happen. Try to mitigate the risk so we don't get to the penetration test, one, and to do that. The other one is that so we don't have it. It'll get to that if you don't try to cool it off after the fact, obviously. And then we're also getting how you vent that away from the driver, because the first thing you're doing in the scene is you have to, when you pull up, is there a person in the vehicle, can I save them and make the decision to get the person out, or it's just, there's nothing to do, they're dead already, there's nothing to do. And that's your first decision when you walk the fire, right?
Somebody out regardless, yeah.
Well, if it's too bad, you mean to a point.
No, they're not too bad. There is something there, I mean, well, I'm on the try, you know, not to get too much into that, but I'm going to attack this at one way, either to just mitigate
the person,
you know, even if there is no light to save at one point, but
Yep.
something to touch base on is much of the tech that's out right now for fire mitigation and sustaining propagation in cells. They're using some materials that were, they're great materials, you know, but they're not built to sustain to these kind of temperatures. For that, when you start talking, definitely with prismatics and pouch cell designs, not so much on the 18650s. I mean, I love these things, the Roman candles when they do go off, but they're so thin and light that they heat up real quick and then they cool down real quick, especially if they dump that inner material right out of it. With prismatics, they usually don't. Same thing with pouch cells, so you have this black mass that has a whole lot of carbon and a whole lot of metals into it that hold the heat. With the prismatics, I've seen plenty of them that actually, when at just a 100% state of charge, they will pretty much self-melt down.
Correct.
Now,
fire.
This is at 100% state of charge. If this was set at 30% state of charge, you'd be lucky to set there and sustain a flame. It will still run away, but if you put water on this situation here, the state of charge changes that output, the energy being generated in the cell really quick.
I know we're right at getting close to the end of time. Any questions for anybody? Again, always welcome to hear what's out there, what you've heard, what you've seen, or what's next. So
I've been in flashover simulators and connexes, and the connexes do it over and over again.
Say it again, man.
I've been in flashover simulators
Yeah.
and connexes, and no damage. It doesn't touch them.
correct.
So basically, with this stuff, it seems like the best idea is containment.
Containment and control, yeah.
If you can't, but if a connex can't contain it,
You can
what do
contain
you
it
use to
inside the
contain it?
connex. The connex. So I pulled the connex down.
Okay.
And I don't have a dump tank. I could some, if I needed it, that's why I got my tank. But I was able to maintain this whole vent in that connex. If the doors were shut, it may change slightly, but I was able to do that with just a little bit of water I had on the engine. Didn't need to pull any extra. I wouldn't go in there and start to attack this. The problem with going in and attacking this situation, other than it's quite aggressive. As soon as you start putting water inside this, you may dumb down the fire, but you're going to be causing the cells to short circuit, and
You create more problems.
it may help, it may not. I mean, if them cells dump all their energy, and the other issue is if you put water inside there, you generate hydrogen, because that's how you can make hydrogen just by shorting a cell into a bath of water. So making a more explosive gas is probably not a good idea. So if I was to come off on this as a 9 to 5 job with fire department, I'd shut the doors and go over there with water and just throw a sprinkler on the sucker and let it go.
Which is what we did in Morris. So we worked with, there was 100 and they rallied 7 departments. There was almost 200 firefighters on the scene of those shipping containers that were on fire. We rallied them to actually help them understand. We shut the doors on the container. Every 15 minutes, they would open the container. We would spray down long enough to use infrared cameras to make sure where the cells were and their reactivity inside. This was a megawatt hour was on fire. We were looking for those cells, looking where they're at in the thermal runaway profile based on the chemistry and based on the format. We'd cool them down enough so the cameras could actually see what the temperature was and tell that it wasn't all flashed out. As soon as we could see that it was cool enough to see the temp, we'd shut the doors again, let it continue, and they continued to just spray water around the local area, but nothing on the fire. So, in that case, we took a fire that should have been probably burning for about 2 days. We arrived on site about 7 p.m. They were home by 11 o'clock, fully charred out, fully done. It ruined the entire container. Everything around that was part of it is completely charred. It's a big pile of ash, but it was gone. Versus they had been fighting it for almost 12 hours in the morning and were making it worse and worse and worse over the case. So.
There's still a whole lot of energy. We got this fire burning, kind of like gasoline. It's going to sit there and burn, and it's just going to burn at that temp until it runs out of oxygen or runs out of fuel. The energy that's still trapped inside this cell, or these cells that are in here, these bus bars falling apart, that's liquid copper at that point. That's the plasma. So them are things to think about. As soon as it starts getting up to that temperature, plastics definitely melt, obviously, and then things start falling into places they shouldn't be, and that you get that big release of plasma and molten metal getting spit out of the sucker.
So yep.
One on the left or right, don't matter.
I'm a firefighter on the track rescue team out here in Indianapolis. Have you done local training, or would you do local training for our team possibly if we get you connected?
Yeah. Yeah, so I mean, that's just about a weekly thing now. So yeah, if you guys are interested in that, we can definitely get you some cards. So our local training, just to go ahead and open it up, they can, we do weekly training for customers and OEMs, and we tune them for however they want to be. But for the fire department, you'll see a few similar slides in here, and then we go into a whole lot of detail on mitigation and how to prepare yourself for that after fire event. And then if you guys have a place or need a place, we can do a live burn too and let teams get used to getting into this.
Track. We have a training weekly where one day's our IndyCar certification, the next day's our NASCAR certification.
Yep.
And now we got IMSA and some other stuff we're going to incorporate that.
Yeah, we do full vehicle fires as well with folks. So we've done, the last one we did up in Chicago was a pack fire. So we're able to go up there and show. We can do vehicles if you want it. We have access to pretty much anything you want, along with racing stuff. So yeah, there's an advantage to. We'll walk you through kind of the entire stage and do live. So the way to put it, put an event and then let your team actually see the differences on how you react to that and what you react to that, what it does. I don't know of anybody in the world who does that today. Is that you can not only see it, but you can actually experience it. Get the full live all the way up to full scale, and then see what those differences are.
I'll get your guys' cards afterwards. Get it to IMS.
Yeah, it's worth the show. Definitely, we can get to this. Get to doing that. 'Cause that sounds like a jet engine going off next to you, and when that bus bar pops, yeah, there's some noises that people are not used to hearing. All right, what do you have?
So after the fire job, say the entire pack didn't go off, or if you have set of cells that had been damaged but hadn't caught on fire. What's the best way to dispose of those safely? How do you get those to a recycling center? How do we?
I'll take that one.
Throw them in the trash, right? But they're dangerous.
Yeah.
The pass is swollen. You can see that this thing is up and up, right?
Yeah.
So, what are the best practices when it comes to safely disposing of damaged cells?
Yeah, through UN, there's a couple different methods that you can do today. We have some recommendations that kind of go above and beyond that. Typical recommendation, you do have to put them in an appropriate UN-rated container, which is a metallized, non-burning container. You can ship those around, but you do have to ship them in what they call a known state. They're also a destroyed state. It's very expensive to do. The risk is there. If you look at what happened up at Morris, they started packing up shipping containers under the UN spec. They actually had some shipping containers that actually caught fire on top of the semi-tractor trailers that they were on. So the driver noticed, got out, smelled something really hot, put his hand on the side of the container, realized he burned his hand on the side of the container, went back and opened the container, and there's fire inside. And these were from products that have been setting for almost a half a year. You can do that, and it works. Our typical one, and what you'll see with a lot of recyclers, is you either got to do a deconstruction method at the site of where you're doing the mitigation, and or what we do with ours, and is actually clear today, is we actually finish them out. That's part of the reason when we think about fires, we wind up letting them go and wind up encouraging them to finish out. Most of Rodney's job at the end is to actually take those and finish burning them, to complete char. So you either got to disassemble them and get them into an unknown state, breaking them down into a cell level where you can package those easier, reduce the amount of energy, and or you can ship them approved, but just know that there is obviously a risk depending on how large that system is, or you go through a full deconstruction, which there's at least those three methods, and there's a ton of subsets that are underneath it.
There's a water method that you can use, a dunk tank style, but there's
sand and water and vermiculite storage or one other, but
there's some science to get into there and make sure that you're not also making a hydrogen bomb. So you can discharge the cell slowly through a salt solution water, but like I said, you are making hydrogen. So we're working on the investigation on the electric vehicle fires that are happening because of vehicles that were in Florida. People are probably familiar with the storm. So we're part of the investigation team that's helped with that. It was funny, they were in salt water, which actually is what caused the failure. They weren't in there long enough to actually mitigate the risk. They were shipping them around now. They started putting them inside of, someone recommended to put them inside of Connex containers that had salt water inside of them. They caused a bigger issue with that as well. So rather than breaking them down, properly handling them, they put them into a method that
what would have worked at a module would have worked at a cell level is not going to work on a 100 kilowatt hour, 90% plus state of charge battery pack. The hydrogen release that was inside of there and the amount of time that it took, I mean, they're looking at keeping it in there for probably a year or more, not keeping it in there for days. And so we're working with them on methodologies to actually break those down, basically destroy those battery packs versus some of those other storage methods. So.
What do you do to char to get rid of it for that? It's still in a state of that as a recyclable black mass thing?
Yeah, great question. Once they're charred to what we call a known state, there are checks you have to do. They get disposed as standard disposal. So it's universal waste at that point. So
Is it identical with the metal still in it, or what is it?
it does have the metals in it, but they consider it metals and carbons.
You could recapture that in black mass and recycle.
Correct.
That's what they're
Yeah,
doing.
yeah,
There's a value. It's worth money. Don't throw it away.
people will universal waste it if it's small scale, but obviously we encourage it's recyclable.
Black mass
Yeah.
is the term that we use
Yeah.
to go to a recycling
Yep.
center to do that.
Yep.
On that one. Cool.
Sorry, I know we're way past, but another question.
We're just asking questions, sitting down.
Yeah, that's good. Yeah.
Yeah, one question is, when you come up with a particular vehicle, you know what the battery chemistry is because it's whatever came in the vehicle. Like at a race track or something like that, people are doing different stuff. And how do you know what, because you're talking about how every different chemistry would have some different strategy. How do you know what it is when you walk up to it?
You will not, and that's actually one of the things that we've discussed around is how do you put appropriate rule sets in place where you can start to determine through placarding and others what's there. So similar to how you would have an understanding of what's in different vehicles. There are obviously fuels that go with known vehicles, but across some of the other custom classes you may not know what's in there. How you deal with a nitromethane or an alcohol versus a gas fire, a race gas fire. We're looking at the same thing with a lot of the, not only do we work with NFPA, UL, FDIC, and all those on the going to commercial market, but really starting to, and unfortunately, I think they're being smart and they're asking the right questions. A lot of our racing bodies today are kind of behind as well on the understanding of how to apply good methodologies and also what kind of rule sets should they put in place so that they can walk up to the fire, know what it is as best as possible, and have a keen understanding of how they react to it, and also the things they shouldn't do. So, how do I react of, kind of an internal combustion engine fire of any variant to, a battery fire, and how do I handle that variant as well?
Like at your organization, are you doing things like spectroscopic techniques or something like that to see what kind of metals might be present?
Correct. Yeah, if you look at all of our fires, I mean, Rodney showed you part of the data set, but any fire we do, we're doing gas analysis. We've got particulate analysis, lets us know everything that's contained in that fire, where we showed you, earlier those examples of, chlorides, fluorides, bromides that are in there, H2, NO, CO, CO, that's in about every fire. And then also all the HF components. We have to qualify those for our customers. So they have to know whether we're burning a power tool or we're building, I think this week they were burning a excavator battery pack, a several hundred kilowatt hour battery pack that's, quarter the size of this room. We have to quantify what's in that for the manufacturers going into the field. And so, as we think about failures, we have to translate that into what are you going to be reacting to out in the market. Yep.
With your background in motorsports and first response, as far as the smoke, gases, do you see that there's more of a need for SCBAs possibly in the future?
That was on one of the slides which we didn't cover, but SCBA blow through is a reality.
The gases that's being released off, obviously you don't want that on you or in your breath or in your lungs and on your skin, because HF can still in a liquid form pass through and get in there. Not to even talk about whatever cancerous causing material is inside there. But the HF is the one to be really concerned about. You do not want that in your lungs. SCBA pack up. Going into that, you're going to have to think about how long the chemicals that are coming off these battery fires. I know that a lot of the track guys are thinking, oh, save my car. Honestly, there is after an event like this, if I have any metal that's around that environment, it is so corroded up that I have to go in there and wire wheel that stuff down sometimes just to get the corrosion off there from a day or two later. I mean, it's heavily corrosive and accelerates faster than what you're used to. So there's some testing to be done there on how that's going to act too with the SCBAs and some of the materials in there.
Yeah, we're finding with some of the SCBA, depending on what they're rated to, like at Morris, the one department that was there, a couple of the department guys noticed as soon as they walked up, I mean, they had some newer turnout gear when they were there. Several of the operators said, there's a unique smell coming off the cabinet. I'm not sure what it is. And I said, well, what do you mean? I said, when do you smell it? And I said, like, with your mask on or when you were just standing around the site? I said, I'm smelling lots of stuff right now that I can describe to you. And he said, well, it's this like sweet smell. One guy said, it almost smells, he's like, I've never done marijuana in my life, I swear, but he goes, it smells like something so succinct as marijuana. I said, that's the electrolyte breakdown. That's the organic solvents that are breaking down. But what you're smelling is as it transitions, that's the combination of HF and some other stuff in there. And I said, did you get that in your mask? He said, yeah, when I was standing there in just the flume with the other guys, I noticed that my mask really wasn't doing any good. He said, it was blowing through everything. And I said, yeah, that's because your filters are saturated and or they're probably completely oxidized or ate through. And so you were getting short-term exposure to elevated levels of those solvents. And so that's one of the things we had to tell them is that some of your gear today, a lot of it is actually not rated for that. Same as voltage. They were that cabinet was 1,000 volt rated when we were starting to show them the rating on their gear. A lot of them had 600 volt rated gear. So they weren't even, isolated from that perspective. So again, to demystify it a little bit, I mean, that's forthcoming. I mean, Rodney's actively working on even today racing suits. So we've got racing suits that we're looking at how do we qualify racing suit, racing gear for voltage, for chemistry, for those other things. So I don't want anybody to leave the room thinking like, oh shit, like we got to stop till all this is solved. It's already, those solutions are underway. So, a lot of that testing, a lot of that capability is coming forth with there's folks like, Rodney and our teams that know what's in those today, so we're trying to help put those into the products that you guys are all using today as well.
If you got a fire, you just got a car, just got a crash, and you try to get on the driver, what you would use? A CO2 extinguisher, a powder?
Get out the driver, what would you use?
Do we have, so there is some Litex that can be utilized, it serves its purpose.
You think about on a racetrack, for example?
Yeah, exactly. You got a crash, you don't want to put water, but...
Yeah, ideally on a racetrack today, I mean, the initial first response is water around the area where you need to get life out.
Yeah.
Beyond that, I mean, we don't like to use it as hard to say we don't give a shit, but beyond that, is you really got to consider whether that track or that racing agency, has contained areas. There are, today we have methodologies where you can spray water. Just know that that's probably going to stay a sustained area for a really long time and you're going to shut the track down. We have some others where we're looking today, we're doing some liquid nitrogen studies, which is actually proving very, very well. We're working with agencies to create kind of a modern version of a fuel cell for a battery for the OEMs to create a port that allows the injection of liquid nitrogen. Liquid nitrogen is proven very, very well, by the way, does not stop the fire. What it does is basically pause the chemical reaction. It literally puts it on freeze. We're injecting that plus another chemical in that allows us to safely pause the fire and take it somewhere else. As soon as you reduce that application, though, it does go back to thermal runaway. And so as we think about tracks, what we're helping them consider, in fact, this is literally some testing that Rodney has already done in our team, along with AVL, Amphenol, and some of the biggest companies in the world. We have tested out liquid nitrogen, not saying that's the end all, by the way, but a liquid nitrogen application, an injector that actually allows us to, for racing and for safety, to be able to move that event. So again, we're not stopping that event, we're pausing that event, kind of putting it in a controlled state or a known state, we take it somewhere else. And as we think about a racetrack, we would take it either potentially offsite or at least move it to an area where we can let that thing continue its, joy over here. There's a campfire going on over at the side of the track. Just ignore that so we can continue on. So as we think about racing, it gives us the opportunity to do that. As we think about first responders, same thing, is they can at least get it off the roadway. And as Rodney said, maybe put it in the ditch and get out the marshmallows, and let it finish out. But at least you've saved the human life and saved the property as best as possible. So.
Yeah, it had really based on scenario on some of that stuff.
Yeah.
I mean, I can run 100 different ways I do it through my head, but I know that's not going to matter once I use that. Once I throw the hard hat on.
Have you been exposed anywhere with the Formula E test guys? And
Yes.
Trigo and all those guys? 'Cause
Yep.
That's what they do on site with the first responders. They've got a really good, their
Yes.
program of how to do that was the right one. So yeah, they were the first one.
There's some that got some pretty decent programs today. The biggest thing has been variant of chemistries as they throw that in, helping them understand that they may have to change their methodology again. So
More obviously, and then you got Gen 3 now with change to look at now without that's going to be.
Yeah. Yeah.
Do you guys
Correct.
have cards that we can grab?
yes, yeah, we'll grab some cards for everybody. So, and if you're, I'd love to, if anybody's bored and sticking around through next week, again, we're about 45 minutes from here. Love to take you down and show you the facility. You know, Rodney left a fire yesterday that his team was doing in a good way, by the way. Didn't leave anybody behind. No man left behind. But was doing a fire yesterday. So has got active use of that. So appreciate everybody sticking around with us.
Can I get a card?
Yeah, all good.